Welcome to the channel where all you gotta do is fix this laser cutter that I'm trying to make into a plasma cutter. So I had some failures on my original attempt, and I mean, I'm not above that. Failing is how you learn, right? So I learned. I had a bunch of people comment on what I was screwing up, and I totally appreciate that. So thanks to all of you for commenting. I totally could understand, you know, this thing needing to move farther away because, you know, distance, magnetic fields, travel, and every it's square of the length diminishes it. So totally making this in a different spot was part of my original thought, but I was going to try to make it work not doing that. The other thing that was not part of my thought was, see if I can get back in here, is somebody suggested, and I thank him for that, I'll put his name up here, boopity boop, is to wrap a wire around this. So I just made a little spring, so this thing just pops off, and that makes a huge difference. So now, I don't know if you can see, but it turns on and stuff now, and cuts and stuff now. The problem is, if this thing is really close to over here, it flips this thing out again. But if it's over here, it's fine. So just like, which I could totally just make my parts over there, but then I want to use the whole range of the travel of the machine. So, so I'm going to probably make a few changes. I'll probably make new legs for this to raise it up a little bit. And then since I have to make new legs anyway, I'll move this out of the way and make this remote, which means I have to lengthen all these wires, which is no problem. And then now that this thing works, I'm just going to hook, instead of having this, I'm just going to hook it up to this. It's less wires to get tangled up and stuff. So I'll just take these two wires and run them to that guy right there. And we'll go through this whatever thing here and it'll be fine. So yeah, now I'm going to, now that it kind of works, I didn't need to buy a new plasma cutter. I didn't think I did, but that was one of the options, is to use a blowback plasma instead of a high frequency start plasma. But this seems to work. I mean, I'm ruining this piece of metal, but this is kind of garbage metal anyway. It's hot rolled instead of cold rolled, so it's not really useful for anything except for, you know, making temporary fixtures and stuff. But that little guy right there made all the difference. Took a spring and actually this spring right here, I got my spring modifying tool and soldered it to a connector, soldered the connector to a wire, and Viola, the thing just snaps on and off. So I can just, I might need both hands to do it, but I assure you it pops off of there. Pops off easier when it's within reach. There we go. So nothing fancy, and then I just ran it over here to the ground wire, so that's grounded too. Not an electrical engineer, but I could see a lot of noise coming from not having that, so that's what I figured I'd try. So anyway, I'm gonna cut these wires, solder them, maybe put some shielding on there. Okay, welcome back. So I got some 22 gauge wire, black, because all these wires are black, and I lengthened these 11 wires. I still need to get some like this kind of stuff to go around there, abrasion resistant and whatever. So these are all lengthened now. So now this thing can be, well, it's an additional 60 or 6 feet, 72 inches. All these wires are. So now I can have this thing far, far away, which is going to be helpful, I think. And then the other thing I did was, since this thing needed this thing was the leg, you know, I had 3 of these, and then this was the 4th leg. I didn't want this thing just sitting on the ground or sitting on a table, because there's air vents in there. So I made this little bracket, and there's also a little LED thingy, if you can see it in there, down there, sticking out of the back. And I didn't want this to get tipped over, and that's attached to the main circuit board. So I just made this little bracket up, so now it sits real nice and doesn't, you know, it's nice and stable. The other thing I did was, since I had to make 1 anyway, I thought, well, it's not that much harder to make 4. So I made 4 of these. I just saw cut them out close. I made them like 1.5 inches longer, and then I just clamped them together on the mill, and, you know, flipped them and flipped them and flipped them and drilled the hole. So it didn't take much longer to make 4 than it did to make 1. And now this is a little bit longer. And the reason I did that is this raises this whole thing up 1.5 inches. And I want to make a little, probably the first thing I'll make on this machine is some little, those are supposed to be straight lines, right? And then when you put the metal on top of it, it just sits on those little peaks. And then you can put a trough of water in there, so the sparks just shoot into the trough of water and like that. So I'll make a little trough and just put, you know, 1/4 inch of water in there, and then this will stick up and it'll be fine. So I made this taller to account for that extra hunk of support for the material. So like if you buy a professional, you know, $10,000 plasma cutter, it'll have something like that in there. So anyway, that's the difference between that and that. It's raised up about 1.5 inches. I also have to put some little plastic feet on this. I assume these are for grounding purposes. Since I'm having lots of grounding issues, I will put some little plastic feet on here. And then the other thing that I have to do is these ones have 2 holes drilled in here and here. All of them do, except for over here. There's a hole drilled there and not there. So I'll need to pop this off and drill and tap 2 M5 holes, so this one will sit on the corner like the rest of them. No big deal. So anyway, I'll take it apart, put it back together a little bit, but yeah, we should be shooting sparks here next 2-3 months probably. All right, so there it is. Got its new legs on there. It's still square. I checked the cross corner dimension. So now I just gotta, you know, hook all the wire eyes back up and yeah, give her a whirl. I don't see why it wouldn't work, but you know, I said that about 2 weeks ago as well. So okay, so I got this all set up. I got my confuser, I got my panel here, that wire's going across the road. I don't have that hooked up yet, but all I do is plug that wire in and it will be, but right now I have it hooked up to the voltmeter, the beeper on, because I'm not sure how this G-code works, because there is a laser, which is S, which is normally spindle speed. So spindle speed from 0 to 1,000 is 0 to 100%. So I just want to make sure that every time it sees a G0 in the NC program, that it turns off the laser and turns it back on. So I'm just going to double check that right now. So it shouldn't be a constant beep, it should be like full on beep, beep, beep. So Okay, there you go. So if all goes well, you should be able to just plug this back in. And I did look, one of the, a few of the comments actually said that instead of using a solid state relay here, I should use a pulse width modulated relay, which isn't really a thing, no offense to whoever, but basically a pulse width modulated relay is basically a small solid state relay that turns on a real relay that has more current capability, right? So it takes a small input on a microprocessor and then it closes basically a switch, a MOSFET or IGBT or whatever, a FET of some sort, and then that opens the relay. So you need to supply 0 volts, 5 volt pulse width modulated, and 12 volts to it, because you need the 12 volts to close the relay, because 5 volts isn't enough. So it's more complicated than just getting a 20 amp solid state relay like I have right here. So not the wrong way to do it, it's just a different way, and it's more wires and you need 12 volts, which I totally have 12 volts here anyway that I'm not using. This little black wire, oddly enough, is 12 volts. Anyway, I'll get off my high horse and get my safety equipment out, and we'll turn this guy on and I'm gonna push the button and hope for, you know, glory days. It's gonna shoot a bunch of sparks out of there, so since I'm not perfectly set up here, I'm gonna put my welding backwards fashion statement on top of my plasma over here, just to be, I don't know, a little bit nice to it. It has got plastic bits on it, so there. Okay, ready to rip. Starto. How about that? What does it say? I can't read it. Maybe with some backlighting. No, that just makes it worse. Anyway, I'm gonna call that a success. Still a little bit warm, but I think I need to figure out some settings. That'll be my next endeavor, is to figure out what feed rate and what pressure and what current I want to run on different materials. But this thing totally works, guys. Okay, so I did some test runs here. This one's 25 inches a minute, 35, 45, 55, 65, 75. So obviously 75, 65, 55, 45 don't really work, but actually 35 looks kind of the best of all of them, which is what I started at. So, but 25 looks kind of okay too, but I think 35 is probably where we want to be. I did turn the current down to 20 on this guy. It was at 25. So, I think 25 or 20 amps with this thick material, with different material. We'll have to change that, but that's the winner. Alright, we're going to start making some parts here. I swear to you. Okay, so this is successful conclusion to this video, I think. So that box I made for this test piece, this test coupon, did this for two reasons. One, to figure out the feed and speed and kind of the current on that guy and whatever. But also I needed to know the distance to offset my parts, right? Because I'm designing my parts like you're machining them or whatever in CAD, so there's no offset. But this, it blows a bunch of metal out of there. I need to know how far wide that is. So it turns out it's a little over 60 thou. This is a 788 box. No reason, just I drew a box and that's what size it happened to be. And the part on the inside of the box is 728. So it's about 60 thou smaller, 30 thou per side. So that may be a little bit different when I go to a different thickness of metal and different settings and stuff like that. But it gets me in the ballpark for, you know, we're not trying to make precision, you know, Rolex watch parts here. We're trying to make kind of brackets and stuff. And all the precision stuff I'll drill anyway. Like I'm not going to put the holes in for the bolts. I'll went through that. For the Bronco, I got some laser cut parts and I had them cut the holes in there. Of course, the holes aren't round. There's a little in there where it falls off, and then so I tried to machine it to round, and it was like harder than Superman's kneecaps because of the heat effect zone. Anyway, I'm not gonna drill holes in. I'm gonna make the general bracket, and then I'll put it on the mill and boop, put the holes in there, so that they're round and the distance apart is correct, and then I'll jig that all into the frame, and then spark it on where it needs to be. So anyway, that's the second piece of information I needed, is how big is the kerf, so I can start making the programs. This program here, this light burner program, is, I mean, it cost almost as much as the laser plotter. This is like $100 for the software, and that was like $160, maybe $200 by the time I got extra wire and this and that and the other thing, whatever. So call it $200 for that, and $100 for this. But this makes it nice to move stuff around. You can like import a DXF file or whatever, a JPEG, and you can pattern it. You can make a mirror image of it, like all in the software. So it's pretty useful, I think. And then you can start and stop without using this thing. You can just go, you know, run the G code, save G code. If you want to change the feed and speed on different parts of it, you can do that. So it's way easier than going back into the house where there's warmth and a heater and a computer. So, and I got a crappy computer that I think I'm going to bring out here that I don't have to worry about getting hooked up, because this light burn you can put on 3 computers, which is nice. So I have it on this one right now, which suffices, but I think I'm going to take an old outdated computer that my wife hated and repurpose that. So thanks again to my commenters, subscribers, fans, I don't know what you call yourself, but I appreciate you. Hopefully you can help me more and I can help you more. And we can get into a synergistic thing. That's buzzwords these days. So, till next time.